Good morning. This is Sean Morrissey with MSDN and MSDN TV. I'm here this morning with Steve McConnell, author of the very popular Microsoft Press title, Code Complete. Steve, congratulations on the release of the second version of your Code Complete book. For the folks who have read the first version, what's been updated?
Well, 11 years is a long time in the software industry, and after 11 years, I think many of the concepts in the book were still relevant, but there certainly were some ways in which the book had gotten out of date, at least at a cosmetic level. In addition, I think there have been quite a few advances over the last 11 years, and I wanted a chance to include those in the book as well.
So for those that have read the first edition, what's going to be new and exciting for them?
Well, when I first conceived the second edition, I really had been telling people for years that probably 95% of the content was still on target, and really just the programming languages were making the book look out of date. As I got into the revision, I found that really it became more of an end-to-end wholesale revision where about 500 of the coding samples, in other words, all of the coding samples, were updated to modern languages of C++, Java, Visual Basic, and C#. In addition, there are several new chapters that are much more object-oriented, including a chapter on classes, including the design chapter, which has been thoroughly overhauled. There's a chapter on refactoring, which is new for this edition of the book. And I think maybe most significantly, the first book really didn't deal with object orientation, and so the second edition of the book integrates object orientation into the discussion all the way through the book. I guess finally, the web has introduced some new development modes, or has changed some of the more common modes from longer project cycles to shorter project cycles, and so the awareness of shorter project cycles has also been incorporated throughout.
So Larry O'Brien said, Code Complete second edition deserves to be the most read software development book of the year, a distinction which it will almost undoubtedly achieve. What does your book cover that others don't?
Well, I think Code Complete really is the only book that even attempts to treat software construction in a comprehensive way. There are several other books on the market that treat small segments of the topic of software construction, but really they're pretty small segments. Those books might be, if they were formatted the same way Code Complete is, they might be 150 or 200 pages long. Code Complete is over 900 pages long, so really I think what I've tried to do with the book is quite different than what anyone else has tried to do in this topic area. So I'm not really sure how to answer the question in terms of what does it cover that's different. I think there's really nothing else out there that's similar. I would say that I think Code Complete is probably a little bit more solidly based in research, both academic and industrial, than the other books that are out there. Certainly if you're looking for a one-stop reference to software construction, including some of the related activities like software design and software testing, I think Code Complete's really about the only book that a person would need to look at. It doesn't by any means cover the full spectrum of software development activities, but for software construction per se, I think it's easily the most comprehensive book out there.
I've read that your primary concern in writing these books was to narrow the knowledge gap of software developer between industry gurus and general commercial practices. How successful do you feel you've been in doing that?
Well, I think that's a fairly ambitious goal, and I think that narrowing the gap, the knowledge gap between industry gurus and the average practitioner is not something that a person's going to accomplish by writing one book. But I think that statement really captures the focus of my entire career. Writing Code Complete was in many ways the first step toward that goal, but I think really aimed just at software developers. My second book, Rapid Development, was aimed at trying to accomplish that more for technical leads and managers. And then founding my company, Construct Software, we have a very similar mission. Our mission is to advance the art and science of commercial software engineering, and so we're very focused on trying to narrow that gap. In particular, talking about things like our professional development ladder, which gives software professionals a very systematic way of improving their skills and taking their games to the next level. So I think the book is certainly a step in the right direction. I think for many developers it's really the first rung on the ladder. And it's a good sized rung if you read the whole book, but I think that there are many other steps that can be taken after a person has absorbed Code Complete.
At a Tech Ed session you gave recently, you put together a set of slides covering what you thought were the best and worst ideas of the 90s and 2000s in terms of software development practices. You then envisioned what would be the best and worst ideas of the coming decade. Can you go over these ideas and how they've influenced the new version of the book?
Sure. I think one of the threads from the comments I made at Tech Ed is that I don't really think the themes have changed a whole lot over the last 2 or 3 decades. One of the worst ideas that's been around for many years, 20, 30 years or more, is the idea of code and fix development. Of course, that's the idea that Code Complete is aimed squarely against. I think there are numerous practices that work better than code and fix. That is essentially coding by trial and error, and Code Complete is an exhaustive catalog of approaches that are better than that. I think another theme over the decades has been how to find the right balance in software design. Do we try to design everything up front? Do we design nothing up front? Is design more proactive or is it more reactive? And I think that's a balance that we continue to try to strike as project by project and decade by decade. Right now the pendulum really is on the side of no design up front, and I don't think that's an appropriate spot for it. It's not an effective spot for it. I think what we found over the years is that the sweet spot ranges from a lot of design up front to a little design up front, but there's no sweet spot on no design up front or all design up front. And so I think that's been trying to find that sweet spot has been a common or constant over the decades. We also have kind of a theme of how much design we should do in anticipation of future functionality, and I think again, that's an issue that we've struggled with over the decades, but in general, I think the consensus of the industry leaders is that trying to come up with specific designs for unstated future requirements is too speculative to be effective and generally doesn't work very well. We've also had a recurring theme in the industry of finding silver bullets that are going to dramatically improve our quality or dramatically improve our productivity without really requiring any effort or sophistication on the part of the developers. And at one time that might have been automatic programming, and later it might have been third generation languages or fourth generation languages, and then for a while it was components, and we've had various process silver bullets as well. But I think the recurring theme in that area is that there isn't any single silver bullet. There are useful practices, many of which provide useful incremental gains, but none of which by themselves is going to entirely solve all of our problems. And I think another theme that we've seen over the years is programming by buzzword rather than programming out of genuine expertise. And for a time in the 70s, we could say that we were doing waterfall model programming, and that was thought to be good. There was a lot of unsophisticated or unknowledgeable use of the waterfall model, and those projects turned out very poorly. In this decade, I think what we're seeing is a very similar uninformed use of extreme programming. Informed use of extreme programming can work pretty well for certain kinds of projects, but uninformed use of extreme programming is going to work just as poorly as uninformed use of the waterfall model did. And so I think that the distinction really, we could make a superficial distinction between extreme programming and the waterfall model, but I think the more meaningful distinction really is between informed software development and uninformed software development. And I would rather have informed use of an old-fashioned idea like the waterfall model than uninformed use of what's probably a better idea of extreme programming. And I think that really what we see is people seem to think they can state the buzzword, sprinkle the magic agile water on the project, or the magic structured water, or the magic object-oriented water, and the project will work fine. And that's just not the case. So we really need much better expertise underlying the execution of the project.
In the early chapters of the book, You differentiate software construction from the other parts of the life cycle and call construction the central activity. How important are the other parts?
Well, I think that's an interesting question in that the different parts of the life cycle are important for different reasons. Software construction is the central activity because if we're going to have any software, we have to write some code at some point. So in that regard, construction is the only activity that's guaranteed to be done on every single project. Other activities like software requirements development are probably higher leverage activities in that if we get the requirements wrong, we can spend a lot of time on dead ends or wild goose chases on the project as we design and implement mistaken ideas of what the software is supposed to do. In the worst case, we actually release a mistaken idea of what the software is supposed to do. We miss the mark of what our customers were looking for, and we end up with an unsuccessful product, even though the project might have looked like it was going pretty well. So I think requirements issues are very high leverage and probably have as much to do with the success of the product, whether it's an internal release or a commercial product. Requirements have as much to do with the success of that as anything else. Project management, project planning are a very common cause of project challenges and project failure. Again, those activities are probably higher leverage than software construction and probably more often done poorly than construction is. So an awful lot of room for improvement in those areas. Software design or software architecture especially, again, very high leverage areas. I think done better more often than requirements are done well. They're done well more often than project planning is done well. But if they're not, if architecture is not done well, again, that can really set the entire project up for some significant challenges. On the back end of the project, I think testing is a little bit of a lower leverage activity than architecture or requirements, but again, I think without good testing, you can release software without having a very good idea of what it is that you're releasing. You can release something that you think is pretty good, but without adequate testing, ultimately your users tell you that it's not as good as you thought it was. So I think there are numerous important activities in software. Construction is certainly the central activity, as I said, because that's where the code gets written. And I think as such, it is probably the biggest single influence on the quality of the functionality that gets delivered. But it's not the biggest influence on whether you developed the right functionality or the biggest influence on how smoothly construction itself goes. I think activities that tend to precede construction really determine how well construction is going to go, or at least maybe if they don't determine it, but they influence it to a large degree.
A lot of organizations spend great effort on process standardization. Is it really possible to standardize across all type of projects?
I think that I agree that many organizations have tried to standard processes across numerous types of projects and products. And I think if you go to a high enough level of abstraction, sure, it's possible to standardize processes across numerous kinds of projects. But at that level of abstraction, you're dealing with extremely abstract steps in the process. Those are steps like, we might have very high-level steps like inception, elaboration, validation, that kind of thing. If we get to a more detailed level, then I think it's not possible, it's certainly not very effective to try to standardize detailed processes across multiple projects. I think we can define certain gates that all projects should go through, regardless of the kind of project. Those gates would tend to be things like, do you have a project charter? Do you know why you're doing the project? Do you have a list of what the assets are at your disposal for the project? And do you have a list of what the risks are to your project? I think we can standardize at that level with a little bit more detail than the very abstract view. But I think if we try to drive much below that kind of a level, then we're probably over-constraining the project and over-constraining it in some ways that are not going to work very well for a large subset of the projects that we would try to apply those standard practices to.
Introducing software process has a cost associated with it, as well as trying to enforce that process. How do you weigh the benefits of the process against the cost?
Well, I think, how do we weigh the benefit of processes versus the cost associated with it? There has been some research on this point, And a great deal of the research, I think, is based on fairly dirty data. That is, data that looks at the effects of process improvement without trying to factor out the effects of related activities that don't have much to do with process per se. For the limited research I'm aware of that looks at process specifically, I think that the impact is it's measurable and it's significant, but it's not by any means staggering. The most well-known process improvement framework would be the software CMM, or capability maturity model. And the data on that suggests that if you look just at the process improvements, not at the related training or skills enhancement or improvement in retention or other factors, that the process improvement by itself is worth about 20% improvement in productivity from one level of the CMM to the next. So 20% is a significant improvement, but it's not really an earth-shattering improvement. And the cost associated with that, I think, is fairly hard to isolate relative to the costs of related activities. And I think this is one of the common themes of software research over the years, too, is that most of the research is not done in a controlled laboratory environment. Most is done on real projects. And there are so many confounding factors on real projects that it's very difficult to come up with statistically meaningful studies on the effects of different software practices. I think one of the things that the research is very clear about is that individual capabilities are far and away the largest contributor to productivity and quality. So hiring good people, developing good people, motivating good people, those are the huge factors. And the process improvements are a good second-order optimization, but if you aren't paying attention to recruiting, retention, staff development, then good processes used by bad people is not a good recipe for success. And I'd rather take mediocre processes used by excellent people than excellent processes used by mediocre people any day.
From the Fog Creek discussion board, someone said, if you hire only extremely talented programmers, pay them a lot, stay out of their way, give them a suitable environment and only tools of their choosing, and you test the hell out of the code, you'll always end up with something soon exceedingly good and easy to adapt with new requirements. What do you think?
I think that that's a recipe for a successful project for a pretty small class of projects. If I have a project that can essentially be self-managing, so I have 3, 4, 5 programmers, and it's fairly short in duration so that I don't have to worry about people forgetting what they did 6 months ago or a year ago, and I have software that doesn't operate in a regulatory environment for the FDA or the NRC or the FAA, I think that kind of approach can work well, and indeed many of the most popular products on the desktop today were originally created in mode similar to that. However, once I get into larger team sizes, there's more of an overt management activity that's required. Once I get into longer standing applications that have been around for 5 years or 10 years and have a large installed user base, I think those practices break down pretty quickly. And I think a good way to think about it is in terms of a musical group analogy. If I have a jazz quartet, I can have some pretty nice sounding improvisations if I have 4 talented musicians. But if I want to have 150 musicians, I need a little bit more overt coordination and planning to make music rather than just noise. And so I think for small projects with sufficiently talented people, sure, that's a good approach. And many of us would prefer to work on projects like that. For more ambitious projects, I think that sort of approach is going to break down.
And to what extent should software tools enable the prescribed processes? What's the role of tooling in managing the process?
I think there are always 2 ways of looking at software processes and how to make developers follow those processes. And I always differentiate between good faith violations of process and bad faith violations of the process. A good faith violation is a programmer who wants to follow the process but just doesn't quite understand how the processes work or doesn't have the background to apply the process effectively. Bad faith violation is someone who just is not going to follow the process no matter what. Even if they understand it, they're not going to follow it. They just don't believe in the process. even if they know about it. I tend to think that bad faith violations of process are not a technical issue. They're an HR issue, and they need to be addressed at the HR level. Good faith violations are really the interesting technical topic, I think. And there I think that companies do well to define what I think of as a path of least resistance that is the same as the path that they'd like the development team to use. And tools are a very important element of defining a path of least resistance. If I can set up a tool so that it's easier for a developer to do something the way that I want the developer to do it and harder for the developer to do it some other way, then I think it's very likely the developer is going to do it the way I want them to because it's easier. It's the path of least resistance. Highly interactive tools are a good way to do that. Company culture is a good way to set that up as well. Having a shared team vision of how they want to do the project is another element of that. But I think tools are certainly a very powerful element of that. And I think that there's really no limit to how much we should try to support development practices through good tools. The greater degree we can support those with tools, the more likely it is that people will develop software in more productive ways.
How do you reconcile the different views of a software project that different team members have? Project members tend to look at reported versus planned activities. Developers look at lines of code. Testers look at bugs found and fixing the code coverage if they're lucky. So you see project meetings which degenerate into arguments over whose numbers are right. Can process help address this?
I'm not sure that processes per se can help address that, but I think the question really strikes at a fairly specific topic in the area of software measurement. And I guess what I would say appears to me to be the issue in that topic area is that single dimension measures are, I think by their very nature, prone to misinterpretation and abuse. Anytime we try to measure something using one measure, that measure is going to be subject to inappropriate optimization against that measure. So if we try to measure lines of code produced, developers will look for ways to produce more lines of code, which may not produce higher quality or more functionality. It will just optimize for that one measure. If we measure test cases, then testers will add more test cases that don't necessarily add more test coverage, that don't necessarily improve the quality of the software, but simply optimize against that one measure. And so I think the trick anytime we try to measure something is to come up not just with one measure, but with a set of measures that collectively balance each other out, or that are stressed against each other to some degree, are in tension with each other, such that if a person optimizes one thing that's desirable, they are not also or they may also be de-optimizing something else that's desirable, and that encourages them to try to optimize for the set of measures collectively which is very desirable, rather than just pathologically optimizing for one thing that's not that good if you take it to an extreme. So I guess I would say I don't really see the question as being a different view of managers versus testers versus developers. I really see it more as a question of what development activities and what development artifacts do we want to take a look at that in combination give us a good view into how well the project is going.
In the last few years, there's been a zealous, almost religious debate about agile methods and formal methods. How should a team or organization choose its process?
Well, I think the question really almost answers itself. The fact that there's been a zealous religious debate about Agile is very much a case of the names changing, but the story remaining the same. In the 1990s, we had the same zealous, blistering debates over object orientation. In the 1980s, we had the same debates over structured methods. And so it's no big surprise that in the 2000s, now we're talking about Agile. And I think that the key insight here is not whether Agile is good or bad. The key insight here is whether we should adopt a religious attitude toward software development. And I think the answer there is pretty clear, that religious attitudes are not very helpful in software development, and that whether the religion is about Agile or OO or structured methods, it's not going to be very helpful. And so how a team should choose its methods is hopefully with an absence of religion, that is with a more clear-eyed view of what the trade-offs are for any technique, because there aren't any techniques that are all good or all bad. It's always finding a balance of where the strengths are and whether you can tolerate the weaknesses. And I think Agile practices specifically, at this point in time, I think the word Agile has largely lost most of its original meaning. I think Agile, the meaning of the word Agile today really is a synonym for modern or contemporary development practices. And so to say that we're doing Agile programming, I think is really today, most of the time just means we're trying to use fairly modern and contemporary practices. And I think that's fine. Within the Agile umbrella, which at this point is a very large umbrella, there's a very large set of practices that we could choose from. And so I think the real project success criteria here is not do we use Agile practices or not. It's going to be which of the Agile practices do we select, and then maybe more importantly, how skilled are we at applying the specific practices that we do select. And again, it goes back to the point about individual capabilities. If I have a team of highly skilled people who are well trained in certain practices, whether those practices are called Agile or something else, they'll probably do pretty well. And if I have another team that's not very well skilled in any practices and happens to say that it's doing Agile development, it really doesn't matter what they call what they're doing. If they're not doing it in a skilled way, they probably will encounter a lot of challenges.
So Steve, it's been 8 years since you wrote Rapid Development.
No, it hasn't.
Should we be expecting an update to that book as well?
It's hard to believe that it's been 8 years since I wrote Rapid Development. It really seems more like 3 or 4 years at most. I think Rapid Development is probably doesn't need the extent of revisions that Code Complete needed. I think there are a handful of practices that I would add today in the best practices section of Rapid Development that were not addressed in the first edition. I think test first development would be a practice that I believe I would add as a best practice at this point in time. And there probably are a handful of other practices as well. In addition, I think the case studies in the book are really more client-server oriented, and it would be nice to have a chance to update those to address web development rather than something that at this point is starting to look a little bit old-fashioned. Having said all that, an update to Rapid Development is not very close to the top of my list right now. I have been planning to work on a book on software estimation for several years, and more as a personal challenge than anything else, I'd like to finish that book first. And after I finish the estimation book, then I'll take a look at what comes next. And Rapid Development will certainly be at the top of the list of projects that I want to take a look at.
Steve, thank you for your time, and congratulations on the new book, and best of luck.
Thank you. Thank you for the visit.